found two initial conditions here. For C1 and for two initial conditions, we found the C1 and C2 values. So I'm going to show you how to do that in Matlab, and then I'm going to show you how we can check this. So let's go over to Matlab. We have our previous code here. What we're going to do next is we're going to say trying to find, so not trying, let's be confident, finding the initial, the C1 and C2 from the initial conditions. So let's say that we want to use the solve function. We have a of 0 is equal to, well, it's not a of 0, it's first we need to define the particular solution. So let's be careful here. Defining, and I'll show you how to find the particular solution as well. So let's say I'm going to define the particular solution guess. So that's going to be xp equals to the vector a comma b. A comma b. Okay, so I'm going to add those variables here. And now I'm going to say solving for the particular solution. And I know this is easy, we did it by hand, but just in case something becomes a little bit more involved, you can just plug it in and say derivative of that is going to be equal to a times xp. All right, and we want it to output because we'll pick out the system from this. And dimensions don't match because here I was supposed to put a semicolon and I put a comma. But now that we have this, it should work. So we get a is equal to 0 and a minus b is equal to 1. And I did the same mistake that I told you not to do in the other video, which is you need to add the f of t. So let's define f. Defining the forcing function. Defining the forcing function. And what are we going to have? Well, I'm going to have f of t, and that's going to be equal to just 40 and 0. We can take out this because it's just a constant. And now we're going to pick out the system again after doing Control Enter. And now it's going to be a is equal to 40 and a is equal to b, so b is also equal to 40. However, if you wanted to have Matlab do it, we could use the solve function and say 0 equals 40 minus a and comma 1 equals a minus b, and then we're going to solve for the variables a and b, and we want to rename those same variables a and b. So once we have that, we can press Control Enter, but let's finish up. So checking the particular solution, that's going to be first renaming the particular solution. Renaming the particular solution is going to have xp is going to be equal to the vector a b, and then from this we're going to check the particular solution. So that's going to be the derivative of xp is equal, should be equal to, and equality is given by two equal signs, should be equal to xp plus f. Don't forget that f. We want that to output because we want to check it. And then I'm going to define the general solution, which is going to be just x of t, which is going to be equal to x of c of t plus xp. And now with that general solution, what we want to do is we want to check it. Well, actually, we want to find the specific solution first. So now we're going to say that well, let's check it first. X of t is equal to this. So the derivative of the general solution with respect to time should be equal to a times that plus f. And then from that, we're going to have what are we going to have here? We're going to have the solving for the C1 and C2. So that's going to be the solve x of 0 is going to be equal to what? Well, they told us a1 is 0, a2 is 4. And we want to solve for we want to solve for C1, which was capital, and C2. Look, C1 and C2 here. So basically what I'm saying is if I input 0 in this solution over here, which is this and this, I'm going to get this vector eventually. The vector 0, 4. And by that, I can solve for these, and I can have them output into C1 and C2 separated by a comma. I still want the capital ones. And so then I can redefine the general solution, and that's going to be, again, this. Well, I'm going to have to write this plus our xp, because if I had just written this, then it would have taken, it might have worked because we changed what C1 and C2 are. But just to be sure, now we know what C2 and C1 are, and now we want to check the general solution. So we do what we do usually. We take the derivative of this and we say that has to be equal to a times x plus f. And then we press Control Enter. And here I forgot the double equal sign for the equation. But now that we have all of this, we notice that 40 and 39, so why do we have 39 here? Because I said that this is equal to 1. And where did I get the 1? So here, I found the particular solution, and I said that b, so this is a case where this is wrong, because you need to specify with respect to t. Otherwise, I think it took the derivative with respect to a. So if you do all of this, then this should be 0. So let's recheck that by repressing Control Enter. So now we get what we were expecting. The particular solution is working. Now we find this, the particular solution is checked. We define the general solution, and we notice how we have the 40 and 40 here, which comes from this. So now that we have that, we can check it, and we notice that it's working. Now we can solve for C1 and C2, and we can plug it in. And if we go down, we notice that that works, which brings up a good point, the point that we might have messed up the system before, because in here I had negative 40 and 4. Here, on the other hand, I have this, and it's working, so it's got to be negative 36 and negative 40. So let's see what might have gone wrong here. So here we had 40, 40. You see how here I was supposed to put a 40 and I didn't? So this is a good lesson. Here we were supposed to have a 40 and we'd get C1 is equal to 36, which is what we have over here, or negative 36. Yeah, negative 36. And C2 is equal to negative 40. So this should be negative 36. So it's always good to check in MATLAB. I hope this was useful, and I'll see you next time.